Imagine for a moment, standing on the shore of a vast cosmic ocean. The waves are not water, but the gentle ripples of space-time itself, carrying messages across unfathomable distances. For all of human history, we have stared into that darkness, wondering if we are alone. We have sent our own messages, our own probes, like bottles cast into the sea. But what if, after all this time, a message has finally come back to us? Not a greeting, not a sign of intelligent life, but something more subtle, more profound. A whisper. A chemical hint carried on the light of a distant star, suggesting that the conditions for life, as we know it, might not be so rare after all. This is the story of such a whisper, a discovery that could redefine our place in the universe. The cosmos is vast, almost beyond our ability to comprehend. It is filled with 100 billion galaxies, and each of those galaxies is filled with hundreds of billions of stars. For so long, we could only guess if those stars had planets of their own. To hear a whisper from across the light years, you need a very special ear. Ours is called the James Webb Space Telescope. It is not just a successor to the Hubble Space Telescope. It is a revolutionary leap in our ability to see the universe. Unfurling its massive, golden, honeycomb-like mirror in the cold darkness of space, 1,000,000 miles from Earth, Webb is a marvel of human ingenuity. Its purpose is singular and profound, to look back in time to the dawn of the cosmos, to see the first stars and galaxies forming, and to scrutinize the atmospheres of distant worlds with unprecedented clarity. It is our time machine and our chemical laboratory, all rolled into one magnificent instrument. Hubble showed us the universe in stunning visible light, opening our eyes to its grandeur. But Webb sees the cosmos in a different light, infrared light. This is the light of heat, the light that can pierce through the cosmic dust clouds that obscure the birth of stars and planets. This is also the perfect kind of light for studying exoplanet atmospheres. When a planet passes in front of its star, the starlight filtering through its atmosphere carries the chemical fingerprints of its gases. Let us now turn our attention to the object of Webb's gaze, K2-18B. This is not just any exoplanet. It is a world that has captivated scientists for years. Located about 120 light-years away in the constellation Leo, it orbits a red dwarf star, a star much smaller, cooler, and dimmer than our Sun. K2-18b is what we call a super-Earth, or perhaps more accurately, a sub-Neptune. It is about 8.6 times more massive than our planet and about 2.6 times larger in diameter. What truly sets K2-18b apart is its location. It orbits within its star's habitable zone. This is the Goldilocks region. Not too hot, not too cold, but just right for liquid water to potentially exist on a planet's surface. The possibility of liquid water is the holy grail in the search for life beyond Earth, as it's the one ingredient that seems essential for all life as we know it. Previous observations, even before Webb, had hinted at the presence of water vapor in K2-18b's atmosphere. This made it one of the most compelling targets for further study. But there was always a puzzle. Given its size and mass, scientists were unsure if K2-18b was a rocky world with a thick atmosphere, like a giant version of Earth, or if it was more like a small, gassy Neptune with a deep hydrogen envelope and no solid surface at all. With its unparalleled power, the James Webb Space Telescope stared at K2-18b as it passed in front of its star, not once, but multiple times. It drank in the faint starlight that had been filtered through the planet's atmosphere, and its instruments went to work, dissecting that light wavelength by wavelength. The first results confirmed what we already suspected. The atmosphere was rich in hydrogen, and there were clear, unambiguous signs of water vapor. But Webb didn't stop there. Its precision allowed it to detect other molecules, painting a far more detailed and surprising picture of this alien sky. The telescope found significant amounts of methane and carbon dioxide. These gases, carbon dioxide and methane, are significant. On Earth, they are intimately linked with biological and geological processes. Finding them together in an atmosphere is a key step in assessing a planet's potential for life. But then came the true bombshell. The data that trickled back from 1,000,000 miles away showed a tentative yet persistent signal. A signal for a molecule that, on Earth, is produced almost exclusively by life. A molecule called dimethyl sulfide, or DMS. Let that sink in for a moment, dimethyl sulfide. Here on our planet, DMS is what gives the ocean its characteristic smell. It is produced primarily by phytoplankton, tiny marine organisms that form the base of the oceanic food web. To find even a hint of this molecule in the atmosphere of a planet 120 light-years away is, to put it mildly, a mind-blowing revelation. The scientists analyzing the data checked and rechecked their work. Could it be a mistake? An artifact of the instruments? The signal was faint, and they stressed it needed further confirmation. But it was there. A potential biosignature, a chemical fingerprint of life. This is why Webb is such a game-changer. It doesn't just tell us if a planet could be habitable, it gives us clues about whether it might be inhabited. The collection of evidence from Webb, the planet's size, the water vapor, the methane, the carbon dioxide, and the lack of ammonia, all converge on a fascinating and relatively new concept in planetary science, the Hycean world. The name is a portmanteau of hydrogen and ocean. This is a theoretical class of planet that is larger than Earth but smaller than Neptune, with a hydrogen-rich atmosphere, and most importantly, a surface completely covered by a deep, global ocean of liquid water. K2-18B is now the prime candidate for being our very first confirmed example of such a world. This is a monumental shift in our thinking. For a long time, the search for life has been narrowly focused on finding Earth-like planets, rocky worlds with thin nitrogen-oxygen atmospheres orbiting sun-like stars. But Hycean worlds open up a whole new realm of possibilities. Red dwarf stars, like the one K2-18B orbits, are the most common type of star in our galaxy. Planets like K2-18B, these sub-Neptunes, are also incredibly common. This discovery resonates so deeply because it speaks to one of the oldest and most profound questions we have ever asked. Are we alone? The Webb discovery on K2-18B represents a new and perhaps more promising approach. Instead of listening for a shout, we are learning to see the breath. We are looking for the subtle chemical changes that any kind of abundant life, even simple microbial life, would imprint on its world. Finding a potential biosignature like DMS, even a tentative one, fundamentally alters our perspective. It shifts the burden of proof. Before, the assumption was that the universe was sterile until proven otherwise. Now, we have a tantalizing piece of evidence that suggests habitability, and even life itself, might be common. If life is common, it means that the universe is not just a collection of sterile rocks and gas, but a living, evolving system. It would suggest that the emergence of life is not a fluke, but a natural outcome of cosmic chemistry. The story of K2-18B is far from over. In fact, it has just begun. The James Webb Space Telescope will continue its observations, seeking to confirm the presence of dimethyl sulfide and map the planet's atmosphere in even greater detail. Future telescopes, even more powerful than Webb, are already on the drawing board. They will be designed with the specific goal of dissecting the light from worlds like K2-18B to find undeniable proof of life. We have opened a door, and now we must bravely step through it. This discovery is a powerful reminder of why we explore. We do not do it for profit or for conquest. We do it because we are human, and it is in our nature to wonder, to question, and to seek what lies beyond the horizon. The quest to find life elsewhere is a unifying one. It transcends national borders and cultural divides. It is a shared human endeavor that speaks to our deepest hopes and our most profound curiosities about our existence. What will it mean for humanity if we confirm that there is life on K2-18B? It would surely be one of the most significant discoveries in human history, on par with the Copernican revolution or the theory of evolution. It would force us to see ourselves and our world in a new light. The problems that divide us on our own small planet might seem less significant in the context of a living cosmos. It could inspire a new sense of global stewardship, a deeper appreciation for the preciousness and rarity of our own biosphere, our pale blue dot in the vast cosmic sea. So as we look up at the night sky, we can now do so with a renewed sense of wonder. We are living in a privileged moment in time. We are the first generation of humans to have the technology to realistically search for signs of life on other worlds. The whispers from K2-18B, carried on ancient starlight and captured by our magnificent telescope, are telling us that the universe is more amazing, more complex, and more full of promise than we ever knew. Our journey to the stars is just beginning, and the cosmos is waiting. We have only to keep looking up.